Welcome to your premier destination for mastering concepts. Crack IIT, NEET, and all board exams with us.
Slide a heavy box across a wooden floor or roll a marble through tall grass, and the result is always the same. Within seconds, the motion decays, the object slows down, and eventually it comes to a complete, quiet halt. Living our entire lives in this environment teaches us a very specific lesson about how physical reality works. We learn that resting is an object's default state, and that keeping anything in motion requires a constant, active application of effort. But shift your perspective to the silent vacuum of space, and that entire earthly logic falls apart. Out here, massive planets and dead moons maintain continuous high-speed orbits for billions of years, entirely on their own, without a single engine pushing them along. It presents a glaring contradiction. Why does a planet get to glide through the void indefinitely, while a block of wood on Earth demands constant pushing just to move a few feet? The truth is, our daily lived experience is deceiving us. The constant slowing down we see all around us masks the strict universal rule governing how motion actually operates. To understand that rule, we have to establish the universe's ultimate baseline. Imagine a pristine setting, like a soccer ball resting quietly on a flat patch of grass. In an ordered universe, objects possess an incredibly stubborn tendency to maintain their current status quo. If a thing sits still, its absolute preference is to stay sitting exactly where it is. This schematic visualizes that resistance, a perfectly stationary circle sitting on a grid. Physicists call this inherent stubbornness inertia. It's the built-in refusal to accept change. And that status quo remains unbreakable until violently disrupted. You must apply an external, unbalanced force. Translating that schematic into physical reality requires immense aggression. Watch the sheer physical deformation as the boot crushes into the leather. The ball isn't yielding willingly, it is being aggressively compelled to move. A resting object will never, ever initiate a journey on its own. It must be forced to abandon its spot. Now, let's look at a subject that is already in motion, like a skateboarder coasting down a long, flat asphalt road. Here is the highly counterintuitive flip side of the law. Once that initial force is applied and the object moves, it establishes a brand new status quo. Its absolute preference is now to move in a perfectly straight line, forever. Maintaining that constant forward velocity takes absolutely zero energy or effort from the object itself. Which brings us right back to our original problem. If moving objects naturally want to coast in a straight line for eternity, why does our skateboarder eventually slow down and stop? This diagram shows what happens in the earthly environment. The moving shape crashes into an invisible wall of opposing forces. The asphalt's rough surface creates friction against the wheels, while the atmosphere acts as physical drag, pushing back against the rider. The skateboarder isn't running out of internal energy, and they aren't naturally coming to a rest. They are being violently arrested and robbed of their momentum by the environment around them. You can feel this exact physics happening inside a familiar, everyday environment. Picture a full coffee cup resting securely on the dashboard of a moving car. Suddenly, a hazard appears in the road, and the driver slams on the brakes. The car's forward momentum is aggressively halted by the friction of the tires. The coffee cup instantly flies forward, spilling everywhere. But the cup didn't throw itself. It simply obeyed inertia. It stubbornly tried to maintain the car's original speed of 60 miles per hour, completely ignoring the fact that its environment had stopped moving. Every time you spill a drink in a stopping vehicle or feel your seatbelt catch, you are having a direct, localized encounter with the universe's strict mandate against sudden change. Now, pull away from the car and look back out into the frictionless expanse of the night sky. Without an atmosphere to create drag, and without a surface to create friction, orbiting planets are doing the exact same thing as the coffee cup. They are maintaining their speed undisturbed, locked in a stubborn state of perpetual motion. In 1687, Isaac Newton formalized this observation into the bedrock of classical physics. We know it today as Newton's first law, the law of inertia. The universe is never actively trying to slow you down, and it isn't trying to keep you moving. It simply demands that an outside force arrives to alter your path. Until then, you stay exactly as you are.
Thank you for exploring the universe with us. Subscribe to Fundamental Physics for more.